Hello, everybody. This is the presentation for our game Cheesy by Tristan James, Satoshi Muta, Ethan Martincourt, and Tanner Unsworth. Here are the team members yet again: Tristan James, Satoshi Muta, Ethan Martincourt, and Tanner Unsworth. Overall view of the game idea. Well, the main idea of the game was about a 1v1 versus game called Cheesy. It stars two rats named Cheddar and Mozzarella, and the main goal is to see who collects the most cheese to win. But you gotta watch out for those bad, naughty cats who are in the level and are trying to chase you, hunt you down, and stop you from getting all the cheese. We made this game via Unity engine due to its simplicity and how excellent it is to make 2D games. And here's a transition slide for our demo video. I'm going to edit this out in post. So yeah, enjoy the video. Okay, we're here, I think. We're here. So, okay, good evening, everybody. My name is Tristan James, and I will be your guide today for the, simple gameplay demo for my or our group's game, Cheesy, with me, yours truly, Satoshi, Ethan, and Tanner, respectively. So let me just play you a short demo and maybe I'll explain some stuff along the way. So as you can see, it's just a simple main menu. Oh wait, sorry, I forgot to do one thing. The online multiplayer. Hold up, whoops. Okay, I can cut this part out in post. I can cut this part out in post. Yeah, 1 minute already. Okay. So, as you can see, we're able to do some online multiplayer right here. There's more than one player, and let's just open player one's end right now, and let's just, I don't know, you could just name yourself whatever you want. Uh, I don't know, Jackson or something, and then, I don't know, hit host. Maybe go like right here, for example, and for this guy, oh, let's call him Bob. So you see Bob and, you know, Jackson they're on the same server. And as you can see, let's observe the AI first, okay? So the AI is constantly, chasing the one who's closest. They're using the A star algorithm to find their end goal, which is like the player's location. But if we somehow run away, it'll idle for a second and it will start to roam a little bit, like, you know, search the surrounding area, change up its position, and, you know, make it a bit less predictable. And then as you can see right here, he's like roaming around like where are these guys? And then if I come over here and then it's like oh, there you are. Okay. It's trying to like, chase me down now. It's going into its chase state. But once it like loses me, it goes back to like idling for a bit. I mean, just he'll idle, be like what, and then roam around again. But in a certain scenario, Sorry, let me just, pull these two together. We could, um, you know, if one of them is closer to the other, sorry, it's kind of hard to, I don't know, bring them here, yeah. So, hold up, let's use this as an example. So, okay, it's chasing me, but if one of them is closer to the other, it'll start chasing, him. So, yeah, they stopped going after Bob, and then now they're going after Jackson. They do this with the decision-making system, the, path-finding system, and the state machines all at the exact same time. And these two players can interact with one another. As you can see, they're touching each other, they're, touching the enemies, going around the map, seeing each other, you know. Oh, they could also interact with objects a little bit. All right, my apologies, folks. Had some short technical difficulties, and yeah, let's go back. Finishing up the networking session, I could show that, you know, uh, show that they could both interact with the objects. So let's say one is, collecting the cheese and then, disappears on the other's end, and the data gets transferred to his end as well. And let's go over here. Let me just shrink this a little. Sorry. Yeah, let me just shrink that. And then if this one eats that, then it disappears on his end as well. So as you can see, they can both interact with each other. They can transfer information on the enemy's locations. They could, go around the obstacles and all that. And then they could, interact with each other in the objects in the level. So yeah, that's pretty much it for the short demo. I really hope you enjoyed of what you've seen. I'm probably going to use this as a capstone personally, but hopefully you enjoyed it. So, see ya. With the demo, and now we're back. So, I'm going to show you some code examples uh, while I explain what we learned. So, during this entire project, we learned, new techniques for both of our classes in AI and networking, so we can understand how the inner mechanisms and workings, correlate with one another. So for the networking side, we learned a lot about how to connect the client of the users to the online server, transfer information with each other's each player's status to the other players, and the server to the client, to their client. For example, as you saw in the demo, you've seen that the cheese, if one of them ate the cheese, then the information gets registered to the other user that says, oh, this user ate the cheese in this location, so therefore it doesn't exist anymore on both of your ends. Or how it updates the player's position on not only the on player one's end, but player two's end. And how they could, interact with game objects. As you can see before, we got the other player, the collectibles, and the enemies that are chasing them down in the level. As you can see right here, we got the game manager, uh, the code for it right here. It shows client, states, player name, the changing states, got host, server, client, the game modes, the map loading, you know, and more for the AI side of the spectrum. We learned how to use state machines to affect the gameplay, so it'll be more interactive with our users in certain scenarios. Like, for example, with the state machines, if something doesn't happen for a little while, then they do like a certain action until they're told by the decision making system that we'll describe later on to change that state to a different state, like chasing or roaming around or idling for a few seconds, etc., etc. We also got the pathfinding in the game that allows us to, make the enemies move to the end goal, which is the player's location. It figures this out via the A-star algorithm in the code. So it scans around the general area and tries to determine which path is the best path to go. And for the decision-making system, it helps, connect the state machines together to make the AI more interactive with the users. For example, if the player is nowhere in sight and the the enemy doesn't know what to do for a few seconds, it goes into its idle state, decides on what to do, and if it doesn't detect any enemies around, it chooses the roam state and roams around the general area to change its position instead of staying static in one spot until a player approaches, like a lonely guy by a bus stop. And as you can see here, we got like the states, text, got the pathfinding code, the idle state, the pursue state, the AI asset manager or state manager. Whoops. Oh yeah, this one helps. Right down here helps with like the decision making. So there's like some decision making code down here. Yeah, a simple decision making system. Some more pathfinding code that connects with the path node. And here is the flee state to, help make it flee if if it gets a little scared, I guess. And a short summary of what we learned. We learned to fully utilize the ways of networking a client and server to connect players with one another across the world by sending tons of information to each end by nanoseconds. And for the AI, we learned the inner functions of how AI behaviors work in video games, whether it'll be an assistant or an enemy, and how they make those said decisions via the three systems of pathfinding, state machines, and decision making. And that's the end. I hope you enjoyed our little recording recording our little demo, and I hope this pleased you.